We are live now, finally. All right, so 1.7 exponents, real quick recap. The exponent we know, the base is the base, and what does an exponent do? Tells you how many times to multiply the base times itself. All right, Adam and Ashton, Lauren just saved you, so you guys owe her big time. All right, here we go. So, simplistic A, we know. Let's take the base and multiply times itself 3 times. Uno, dos, tres. Si, senor and senorita. No senoras. No. All right. And piece of cake, no sweat. We all know that's 125, right? 125. Now, I'm going to pull back and look at B and C. Here, I'm just going to focus your attention. Look at B. You don't need to do this. I'm just trying to focus your attention and look at C. Are they the same? Yes or no? Are they the same? And the answer is the equivocal French, no. All right? They're not the same. Do students treat them the same? Yes. Big problem. Because you're going to end up with the wrong answer. So in B, it's clear what the base is. The parentheses tells you the base. The exponent is right next to a parentheses. Henceforth, and to it, the base is everything in the parentheses. So technically, this is negative 2 times negative 2 times negative 2 times negative 2, right? Negative 2 times itself 4 times. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. And the answer is 16. However, in example C, I'm going to put that black negative and just keep it there. This is not negative 2 to the 4th power. This is negative a 2 to the 4th power. So this is negative 2 times 2 times 2 times 2. And this one ends up being negative 16. And 16 don't equal negative 16, right? It's not the same. So beware of that. That's what's going to happen to you guys, and you've got to be aware of it. You've got to be careful. Now, I will tell you this. When there's an odd exponent, 3, 5, 7, 9, 11, 13, 15, etc. When there's an odd exponent, in that instance, the two are the same. Those are both going to end up being negative 125. Because what happens with an odd exponent, you're multiplying something times itself an odd amount of times. When you have all negatives multiplied and there's an odd amount of negatives, an odd amount of factors, is your final answer going to be positive or negative? It's going to be negative, right? Because negative times a negative is a positive, but a third one times a negative gets you back to negative. Times a fourth is back to positive, but times a fifth, that odd one is back to a negative, right? Times a sixth is back to positive, but times a seventh, the odd one is back to a negative again. So whenever the exponent's odd, the product is always going to be negative. So on this one, no matter which way you look at it, it's negative 125. That's negative 125. And that's negative 125. For that reason, some will simply take the shortcut and write it expanded like this. Honestly, that's fine. Just be careful. You got to remember, though, you can only do that with odd exponents. If instead you just treat the base like the base and just deal with it, you won't have to remember it's for odds, and you'll get it right every time. So just be careful. Again, a lot of shortcuts are shortcuts. They're nice, but you got to remember them. You got to remember when you can use the shortcut. Well, in this case, you can use the shortcut if it's an odd exponent. So you got to remember that. Well, if you don't bother with the shortcut because it doesn't save you a whole lot of time anyhow, then you're going to get it right. So just be careful there. Okay? So even power, 4 and 4, hey, it matters. You gotta do it. Otherwise, you end up with a different solution. Okay. 2, only applying the exponent to its base. It's the key to it correctly evaluating. Only applying the exponent to its base is the key to correctly evaluating. And again, note the base is only what is directly below and to the left. So how do students get in trouble? Misapplying the base. So let's go through some scenarios. So I'm in color right now. That should make life easy. This is the exact same thing as a 7 times an n squared, right? But we don't bother to write the raised dot. We don't bother with a parentheses because we don't need it, because we're supposed to know that. We're supposed to know that the squared is only for the n, right? That's a 7 n times n. By the way, writing something like that is called expanded form. We're expanding the exponent out, right? 7n squared is exponent form, 7 times n is expanded form. So same thing on b then. So somebody tell me what b would be. What would b be? Ethan, what would b be? Times y times y times y times y, because that's how you do it. That's why. Negative 3x times y times y. And you can put raised dots between them all if you want, but that's the exact same thing, right? We don't need raised dots between letters or between a letter and a number if there's only one. And again, we appropriately apply the exponent. And that's really key. Now, in this scenario, that parentheses is there again. So somebody tell me what to do to expand this one. Nick? Okay, so I was going to use a raised dot. He's going to use parentheses, and that's fine. And that is correct, right? 5 times the 3xy times itself 3 times, right? Because the exponent goes to the 3xy. Now, if you were asked to simplify that, well, it's kind of silly anyhow because we're expanding the whole thing. So if you simplify, you'll be right back where you are. All right, so be careful with that. So let's get down to the exponent rules. So we had this one all last year. And this property is for multiplying like bases. Multiplying like bases. And the property, the rule, is simply a time saver. That's all it is. It's just a time saver. So notice we have like bases. What's the base for the exponent a and x? What's the base for the exponent b and x? The same base, like bases. You can only do the rule if the bases are the same. If you don't have the same basis, you can't do the rule. And hopefully everybody remembers the rule. But in case you forgot, let's go underneath the first example and let's expand underneath. You would agree that n squared is n times n, right? And then I'm going to take my red raised dot, keep that red raised dot. And then what is that, a 6 or an 8? I can't see it. 6. All right, so n, 2, 3, 4, 5, 6. Right? So I did n squared, n times n, raised dot, and then n to the 6, n times n times n times n times n times n. All right, so it doesn't take a rocket scientist. What is n times 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 n is n to the 8th, of course. Now, that took a lot of time. But now we remember the rule is x to the a times x to the b equals x to the a plus b. And I'm going to keep my color. I'm going to do the plus sign in red so it stands out. You add the exponents, right? You add the exponents. If you're multiplying like bases, a shortcut to getting the solution is add the exponents. So if we apply this here to this example, we would have said n, oops, that's a 2, n to the, that's a 6, brother. Get out of here. N to the 2 plus 6. And Ethan, I last year told my students I want to see this rule step. Because every time you write the rule step, it helps your brain to remember the rule. Okay? So I want that rule step shown. Because I want us to keep the exponent rules separate. Keep them squared away. This rule goes with this, that rule goes with that. So this thing is just a shortcut. So now you can see these become very easy. What is this? 2 to the 2 plus 3. And look, again, I know you could do that in your head very simply and say 2 to the 5th. But writing is one more means of remembering, and I'm just trying to make sure you don't get them confused. Because, again, we use exponent rules all the time in algebra. All the time. All the time. All the time. All the time. In this next example, hey, the base is a -7, so keep it a -7. That's all. Just keep it in the parentheses. Add the exponents. So this thing ends up being a -7 to the 8th. Oh, are those parentheses necessary? Any even power, the parentheses make it different values. So yeah, they're necessary. Now, if that would have ended up being an odd exponent, you could drop the parentheses if you wanted to. Because any odd exponent and a negative number ends up being negative. But an even exponent with a negative number ends up even if the base is odd. All right, anyhow, don't want to confuse you. All right, go ahead and do the last example. Of course, I know it's impossible. We didn't do something just like it. How in the world are you ever going to get it right? I'm sure you'll never get it, but see what you can do. All right, try that last example. 3 of them. We don't know how to multiply 3 of them. It's impossible. Never get it right. Did you show the rule step? Is that an 8? 8 and 4 is 12. 12 minus 7 is 5. A to the 5th. How many got that right? You guys are brainiacs. What math whizzes. All right, so hopefully no sweat there. Let's roll on. Property number 2. By the way, we've got a couple equal signs in the wrong spots up there. Are they up there on your notes too? Yeah, I don't know what they're doing up there. They're supposed to be down below, but oh well. First edition in notes, that's what happens. All right, the quotient property. Well, again, you have to divide like bases. So that's the condition. This will only work if there are like bases. Let's do the same thing for the first example. Let's write it out. So is that a 9 on the top? Oh, bummer, man. All right, so look, if you did it longhand, I'm doing the top. 1, 2. I'm doing 9 17ths. 3, 4, 5, 6, 7, 8, 9. Sound like Rocky. All right, and there are 4 17s on the bottom. 1, 2, 3, 4. Right, 17 to the 9th divided by 17 to the 4th. Do you concur? And we know that whenever you have the same quantity top and bottom and everything's being multiplied, you can divide it out. 17 divided by 17 is 1. 17 divided by 17 is 1. 17 divided by 17 is 1. And of course, 17 divided by 17 is 1. And what do we have left? 17 to the 1, 2, 3, 4, 5, 5th power. 17 to the 5th is the final solution. So let's get back to our rule. Hopefully that's a refresher to your brain now, and you remember that x to the a divided by x to the b equals x to the a minus b, and I'm going to write the minus sign in green. So it's the top exponent minus the bottom exponent, right? X to the a divided by x to the b equals x to the a minus b. So now if we go back to number 1 and show the rule step, we're going to have 17 to the 9 minus 4. Oh, this is so much quicker. Again, show the rule step. Help your brain to keep it straight. And sure enough, we get the same answer, 17 to the 5th, right? It's just a time saver. Time saver. Avogadro's number. Ready? Avogadro. He's an important guy. 6.023 times 10 to the 23rd. 23rd. Right? Exponent is 23. You definitely want to learn exponent rules when you get to stuff like that. And again, even the 9th is a pain writing all that out. Just apply the exponent rule and away you go. All right, try number 2. Let's see if we get 100%. Probably won't, but don't be the one to mess it up. Go ahead and do 2. They are like bases, so we can use the rule. Make sure you got like bases. Can only do it with like bases. All right, will we get 100%, Raquel? What do you think? Oh, she's confident in you guys. She has confidence in you guys. She has confidence. And of course, the answer is, oh, I don't want that equal sign yet, is Z to the 11th. How many got that right? Oh, come on, negative the negative. Yes, shame, shame. All right, I knew we wouldn't get 100%, but I was hoping. Watch your negative the negative. Right, and that minus a minus 3 is a plus 3. Yes, it's Z to the 11th. The negative belongs to the formula. The other negative belongs to the exponent. Negative and negative is a plus. Capiche? We got it. Good. Don't make that mistake again. Ever. 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 All right, some of you will make it on the test on Tuesday. Power property. What is it? Exponents raised to another. I'm going to go red. Exponents. Uh-oh. Exponent to an exponent. Oh, no. Oh, my. Lions and tigers and bears. Okay, look at the first example. And again, I'm going to show it to you longhand. So if I didn't know the power property, I would have to do this for number 1. 5 squared times 5 squared times 5 squared. Correct? 5 squared times itself 3 times. Yes? And now I have to do the product property. 5, 2 plus 2 plus 2, right? The first property we learned, x to the a times x to the b equals x to the a plus b, and we end up at 5 to the 6th. But we have a shortcut. We have a shortcut. And we all remember that x to the a to the b is x to the a times b. I don't know, red or something, whatever. Just remember you are multiplying. You multiply the exponents. So again, you come back here, and I don't know that you need to show the rule step on this one. It's so simplistic, right? 5 to the 6th. If you want to, that's fine, but I don't require. So that's a whole lot quicker, isn't it? 2 times 3 is 6, and voila, we are done. Piece of cake. Again, we got to be careful not to misappropriate the base. Let's make sure we're applying the rule to only the base. So number 2 is pretty simplistic. That is 4 to the 35th power. Boy, you wouldn't want to be doing that one longhand. But somebody tell me what we have to do on number 3. What do we have to do on number 3? Somebody tell me how to do 3. Kirsten, go ahead. Okay, so let's, because I like to take things in order, let's take the 7. But then we're only going to apply the rule, and I am going to show the rule step here, to the exponent and its base, right? We're only applying this 5 exponent to its base. Again, this is where you guys get in trouble. That's the base, right? And the exponent. So this thing ends up being 7 times 3 to the 10th. And for time's sake, I'm just going to leave it in that form. If you wanted to finish this out with an actual number, remember, evaluate all exponents first. You have to do 3 to the 10th power on your calculator, multiply it times 7, you're going to get a pretty big number. This 3 to the 10th power is big. All right, take a look at 4. Question. Oh, you're fine. When you have to simplify, then you have to go all the way. So normally it won't be something that big of a pain. You might have something like where you end up with like 7 times 3 cubed. You'd end up saying 27, and then 7 times 27 is whatever value. But remember, you have a calculator with you now, so it's just punching in numbers in the calculator. But I'll usually avoid the gigantic exponents because then you've got to go wrong. We're really going to do all with variables mostly. Algebra, you really don't do a whole lot of the numbers, although parts could be numbers. All right, so look at 4. Here's what happens when you have multiple factors for the base. Look at number 4. The base is an x squared times a y. Now, I want to write it out again longhand because it's going to make more sense to you. So if I did it longhand, it would be x squared y, right, times x squared y, right, times x squared y. Do you concur? Isn't that x squared y times itself 3 times? So you end up with x to what power? Say it if you know it. X to the what power? X to the 2 plus 2 plus 2. All right, better write the rule because, again, see, you guys don't have them down well, right? Times y to the 1 plus 1 plus 1, right? And you end up with x to the 6th y cubed. And that is the answer. Now, by the way, I could have further written x times y times x times x times y times x times x times y, and there would be x times itself 6 times and y times itself 3 times. So students using the rule now, students have no problem doing this. The only question is, what do you do with the y? And usually this is what they write as their answer. Of course, they'll simplify it. And that's not correct, is it? Right now we have x to the 6th y. Was that the correct final answer? No, the correct answer is x to the 6th y cubed. How do you get y cubed using the rule? How do you get y cubed using the rule? Ileana? The exponent for the y is a 1. It's not shown. They expect you to know that. And you have to apply that rule to that 1 exponent as well. X to the 2 times 3, y to the 1 times 3. Now notice we do end up at the correct answer, x to the 6th y cubed. Be careful, students will mess that up. It's the whole base cubed, and therefore we have to do every factor. Okay, so Kirsten asked a while back, what would your final answer be? Well, whenever we involve numbers, make sure we get a final answer. All right, see if you can do 5 using the rule, not the longhand on the bottom. See if you can correctly apply the rule to number 5. See if you can correctly apply the rule to number 5. 5 guys. Maybe, maybe. All right. My advice is whenever you have any kind of factor in that parentheses, stick those ones there, and it makes life hopefully a little bit more realistic. So you have 3 to the 1 times 2, a to the 5 times 2, b to the 4 times 2. I hope you did that. So then you have 3 squared, a to the 10th, b to the 8th. And that would be correct. We will simplify our answer, though. And we all know a 3 squared is a 9, right? 3 times 3 is 9. So it should have been 9, a to the 10th, b to the 8th. Did anybody get that? 1? Uno? Ay, caramba! All right. What happened? How many got at least 3 squared, a to the 10th, b to the 8th? Okay. So again, just finish by simplifying. All right. And the rest of you, doesn't that make sense? You might have said, but it's a number. Last time we did it with the y, and the y was a variable, and the 3 is a number. What if the y equaled 3 in the first example? Wouldn't it just be a number? Any variable just represents a number anyhow. So whether it's a number or a variable, you got to apply it to numbers and variables. Look, if you did this thing longhand, wouldn't you be 3 a to the 5th, b to the 4th, times 3 a to the 5th, b to the 4th? Don't you end up with a 3 times 3 or a 9? You do. So again, you just got to apply it to every factor. 3 to the 1 times 2, a to the 5 times 2, b to the 4 times 2. All right, now that you know it, hopefully you won't miss it next time. I hope. Next! Zero exponent property. The zero exponent property. All right, any base to the 0 power. Base to the 0 power. I don't have time today to go through the whole grouping of why this is what it is. But number 1 is something that you had on a bunch of your tests once we covered it last year. Any base to the 0 power is the blank divided by blank. Anybody remember what goes in the blanks? Nick? The base divided by itself. That is correct. That is what a 0 exponent means. The base divided by itself. So the rule is x divided by x, the base divided by the base, and what's anything divided by itself equal? Uno, sí. 1, right? So students quickly rush to problem number 2 and say the answer is 1. Smart students do 19 over 19 to keep that rule in their mind and write 1. What's the value for 3? Just give me the ultimate value of 3 on 3. Are you ready? 3. Because again, technically it's 5x squared y over 5x squared y. And last time I checked, that's 1. All right. How about number 4? Don't say anything. I want everybody to get an answer for number 4. I'm going to ask you for your answer on the count of 3. Look at number 4. Figure out the answer. You can write if you want, or you can just look at it and figure out the answer. On 3. Are you ready? Everybody nice and loud. Verbalize your answer on 3. 1, 2, 3. That didn't sound the same. All right. If you become an accountant and you misappropriate funds, what's going to happen to you? No, more. If you misappropriate funds, what's going to happen to you? You're going to go to jail, yes, or prison. Yes, you're going to jail, right? Unless you're a politician, then you get fired. Right? If you're anything other than a politician, you go to jail if you misappropriate funds. I started this whole lesson with saying, do not misappropriate the exponent and its base, right? And a bunch you misappropriated the base. You applied the base to something that is not the base. You applied the exponent to something other than the base. So I want you to look at it one more time. And I want you to not to misappropriate the base. Okay? So let's try one more time. Some of you need to convert. We don't have time to take testimonials, though. So on 3, here we go. 1, 2, 3. All right, I heard a lot more of the correct answer that time. This is a negative 7 times x over x, right? The exponent only goes to its base, and negative 7 times 1 is a negative 7, right? Don't misappropriate the base. So really, for number 5, this is a 2 times 1. Do you agree? Right? This is the 1. Yes? Right? The thing with the 0 exponent is the 1. And 2 times 1 is 2. So be careful. Students mess that up all the time by misappropriating the base. Do not do that. Do not, do not, do not, do not, do not. All right. Negative exponent property. Students love this one. X to the negative a equals 1 over x to the positive a. That's the rule. What changed signs? Only the exponent. Did I change the sign of the base? The x was a positive x, it's still a positive x. I didn't change the sign of the base. Some of you will, though, because you'll misappropriate the exponent. Okay, you don't want to do that. What happens? The sign of the exponent changes. On the second one, it's the flip of the rule. If you have 1 over x to the negative a, then this thing ends up being, whoa, should have been blue, x to the positive a. And here's all these are in a nutshell. Change the SIGN. Change the sign of the exponent. Do you change the sign of the base? No. The sign of the exponent. When taking the base and its exponent, only the base, across the fraction bar. Across the fraction bar. Okay, so let me help you guys out. These are too easy to miss, yet students miss them all the time. So there's not a fraction bar shown, but if you'll put one there, all I got to do is I'm going to take the 3 to the negative 2 and stick it downstairs. And look, I applied the rule to the base and its exponent, but I need a 1 placeholder in the numerator, don't I? Because I'm in the bottom of a fraction, I need a 1 placeholder. So I got to have that 1 there. It's 1 over 3 squared, which, by the way, is 1/9. 3 to the negative 2 power is 1/9. In the second situation, technically I could simply do this. Things with a negative exponent in the bottom are positive exponents in the top, right? I just took it right across the fraction bar. What's 1 times 2 cubed? What's 2 cubed? 8. 2 times 2 times 2 is 8. That's an 8. 1 over 2 to the negative 3 power is 8. 8. 8. Uh-oh. We're ready to misappropriate. Look, if I rewrote number 4, you probably won't miss it. Let me rewrite number 4. Would you misappropriate it now if I wrote it like that? Probably not. Here's the quickest way. Draw a fraction bar, take the exponent in its base and put it in the denominator, change its sign, right? Do you agree I took the base and its exponent, I took it across the fraction bar, and I changed the sign of the exponent? Did it have anything to do with that negative out in front? No. This is a negative 4 to the negative 2 power. Now, don't do this. If it would have been in parentheses, then would the negative have stayed with it? Yes, but it wasn't in parentheses. Again, you can't misappropriate. So what does this thing end up with? Negative 1 over 16, right? It's negative 1/16. Look at number 5. Go ahead and try number 5. See what you can get. If you're not done yet, you're not comprehending. So watch. Just take the base and its exponent and take it across the fraction bar. Right? And final, clean it up, x to the 5th over 2. That's it. Right? Take the negative. By the way, technically, you're never supposed to leave an answer with negative exponents. No. Okay? That's not simplified. However, if they're trying to get you to understand things and they ask you to put it in a negative exponent, then you would. Like if they gave this as an original and said, what would it be with a negative exponent? You'd put it downstairs, right, and do 1 over 2x to the negative 5. But normally that's just to see if you understand. All right, one last thought here. Don't let something like a fraction for a base scare you. The first thing I'm going to do is apply the multiplication rule. I'm going to show the little ones for their exponents. So this is 2 to the 1 times negative 2, divided by 5 to the 1 times negative 2. Does that make sense? I'm just applying the exponent to top and bottom, numerator and denominator. So now the top is 2 to the negative 2, right? And the bottom is 5 to the negative 2. You guys with me? Do we want negative exponents? No. How do you get rid of the negative exponent? Not cross multiply. How do you get rid of, although there's no multiplying, how do you get rid of a negative exponent? Say it. Talk. Say it. How do you get rid of a negative exponent? Take it across the fraction bar. Would you agree that becomes a 5 squared across the fraction bar? Would you agree that becomes a 2 squared across the fraction bar? Make sense? Right? Take the base and its exponent across the fraction bar, change the sign of the exponent. We all know 5 squared is 25. We all know 2 squared is 4, 25 fourths. Voila! You are there. All right, real quick recap. Don't pack up yet. Let me just recap real quickly. Just hang in there. Everybody look. Nobody doing anything but looking. So remember, don't misappropriate the base. That's really the key to everything. We've spent some time trying to figure that out. First rule, multiplying like bases, add the exponents. Second rule, dividing like bases, subtract the exponents. Be careful on the minus. Third rule, exponent to an exponent, multiply the bases. Beware of these kinds of situations, right? 0 exponent, base divided by itself. Beware of these kinds of situations. And then finally, negative exponents. Here's the key. Number 1 is the key. Change the sign of the exponent when taking the base and its exponent across the fraction bar. That's all you got to do. You'll be good to go. All right, homework's on the bottom. Do mañana. We finally did something that you didn't know already. Well, what did I do? Oh, thank you. Still recording.